In this video, we will learn how to find out the optimal consumption bundle in case of linear indifference curve. The question is, suppose that a consumer in a two commodity world has linear indifference curve with slope equals to -1/2. Find out the equilibrium consumption when prices for both commodities equal to $2 and income level of the consumer is $2,000. How does the equilibrium bundle change when the price of good X is $1 and price of good Y is $4 with the same level of income? Okay, so we are being told we have the linear indifference curve. Okay, that means our utility function is linear in both the goods. Now, when we have a linear indifference curve, if I draw the graph here to make things clear, let us say we have X on the horizontal axis, Y on the vertical axis. These are the two goods. Now we have a linear indifference curve and it is slope. Slope is equal to -1/2. Okay, let's take the absolute slope because we are interested in absolute slope. So absolute slope of the linear indifference curve is 1/2. To find out the optimal bundle, first let us see what also we are being given in the first scenario, that is price of good X is equal to $2, price of good Y is also being given us as $2, and income of the consumer is 2,000. Okay, let's construct the budget constraint, that is price of good X times units of good X plus price of good Y times units of good Y should be equal to the income of the consumer. So we have 2X plus 2Y is equal to 2,000. Dividing both sides by 2, we get here X plus Y is equal to 1,000. What is the endeavor of the consumer? Consumer wants to maximize utility here. But we don't have the utility function, but we have the slope of the utility function. Now we know that slope of the utility function is simply the marginal rate of substitution between good X and Y, which is equal to the marginal utility of good X upon marginal utility of good Y, and it is equal to 1/2. Okay, the slope of the indifference curve is actually our marginal rate of substitution, or our marginal rate of substitution is actually the slope of the indifference curve. With the linear utility function, with the linear indifference curve, how do we achieve the optimality? We compare the slope of the indifference curve. Okay, so 1/2 denotes the slope of indifference curve, and we equate the slope of the indifference curve with the slope of the budget line. And what is our budget line? What is the slope of the budget line? Slope of budget line, as we know, is the ratio of the price of good X upon price of good Y, which is equal to $2 upon $2, which is equal to 1. Okay, so let us first draw the budget line. Its slope is 1. So let us say here we have 1, here also we have 1. So let us draw, this is our budget line. Now with the given budget line in the maximization problem, what is the endeavor of the consumer? He wants us to achieve the maximum satisfaction. That is, his endeavor is to reach to the highest possible indifference curve. The slope of the indifference curve is 1/2. Okay, so the slope of the indifference curve is flatter compared to the slope of the budget line. Here we have 1, here we have 1/2. Okay, that means this budget line is steeper than the indifference curve. So one indifference curve can be this, so another indifference curve will be like this. So we want to reach to the highest possible indifference curve, so we will get like this. IC, let us say this is IC1, IC2, IC3, IC4. Okay, Here you can see IC 1, 2 and 3. These will not give us the optimality here because we are not getting the optimal solution in the 3 ICs. So optimal solution will lie at a point where the indifference curve and the budget line intersect with each other at one point. So here they intersect. Here they cross each other. They will not give us the optimal point. So optimal point will be at a point where the indifference curve and the budget line touch each other. Okay, so what happens at this point? Since the indifference curve is flatter than the budget line, that means our optimal bundle will be that consumer consumes 0 units of good X and all units of good Y. Okay, that means X is equal to 0. Now we plug X is equal to 0 in this equation. That means when X is equal to 0, so Y will be equal to 1000. That means consumer will consume all units of good Y and 0 units of good X in this case, and we get the corner solution in the first scenario. Now in the second scenario, what we are being told, let me rub this and draw it again. Again we have X and Y. In this case we are being told that the price of good X is 1, price of good Y is 4. Okay, so what will be the new slope? So price of X upon price of Y. Price of good X is 1, price of good Y is 4. So we get 1 upon 4, 1 upon 4. Now let us draw this budget line first and compare it with the slope of the indifference curve. Here you can see the steeper among the budget line and the indifference curve is obviously the indifference curve. So budget line is steeper comparatively. So let us draw the budget line this time. So this is, let us say this is our budget line. Okay, budget line. This time our what we call the indifference curve is steeper. So we will have 1 upon 2. So we will have, this will be, okay, let me draw it like this, 1 upon 2, then we will have another. Okay, I am not able to draw it perfectly, but you can see here this line is steeper than the budget line. Since this is the indifference curve, so it touches the budget line at x-axis this time because it is steeper than the budget line. In this case, what will happen? Consumer will consume all units of good X and 0 units of good Y. Okay, in the second scenario, Y will be equal to 0. So if Y is equal to 0, plug it into the budget equation. So we have X plus 0 is equal to 2000, which gives us X will be equal to 2000, rather 1000. No. Our budget line this time is, we have this very budget line where the price of good X is 1 and price of good X is 4. Okay, so here X consumer will consume 0 units of good Y and all units of good X. We plug here the value. Okay, so in this budget line this time, since Y is equal to 0 in the budget line, so we have X plus 0 is equal to 2000. In this case, X will be equal to 2000 and Y will be equal to 0. So in the first scenario, our optimal bundle was 0, 1000, and in the second scenario we have 2000 and 0. Okay, I hope I make myself clear in this video. Thank you.